Okay.
Well, if you don't mind, you can start. Okay.
Okay. Perfect.
Okay. Okay. Good. Leave it open. I'm gonna close. I'm sorry. I'm gonna close the mic. And if you need something, just open the mic and let me know. All right.
No problem.
Okay. All right. So first of all, I'm going to show you what I'm going to do today. Look, this. I'm still having problem with this connection. So what we're going to do is not at 20-story building. We're going to do them a little higher than that. It's going to be 26, is something like this. It's pretty easy to do it, but there is a tricky way. No, not tricky way. It's another way. I can show you two ways to introduce this building and different ways to analyze it and to do different software. Because as you know, we have our BIM Server Center, and through this platform, we can start introducing a part of the information from this building, may do it first of all in CYPECAD, and then we can export it to the, the platform and work in another software just to get the GIS walls design. And that's the purpose of this seminar. But for now, I'm going to do just one way to do it, which is the old-fashioned way. But I remind you to, I'll encourage you to use the software, and also to be alert, to be on notice that you can use it right now, and you can take advantage of different programs in order to fulfill your requirements using our platform. Okay, so it's going to be like this 26-story building, and and so I'm going to start from scratch. Okay, so we need to name it. I'm going to call these 26 story building. I'm sorry, building with core. Okay, with central core. All right, so I'm going to copy this and put it in the back and in the description. Could be anything, okay? Don't worry about the name. I'm not going to continue with the BIM Server Center. This is an empty project. And by default, we get this information, but doesn't bother, to try to understand about the code and all this part, because you can choose any normative here. If you follow other conference, they show you more in details about how to use this window. And right now I'm gonna set up this team because my purpose today is to show you how to introduce this building, this tall building. Okay, so I'm gonna skip some part of the information because it's not important right now. But also the foundation soils. As you know, we have a table here, but I'm using a good soil. I'm not going to do anything in the foundations, but just to show you where it is. And beside that, I need to introduce in the remaining wind loads and lay loads. About the wind loads, as I am using the Colombian normative because I know I feel better, comfortable using it because I know that normative. So I'm going to use the Colombian normative, but you can work in in different environment. So the size of this are going to be 26 something, like that, because the building in this direction is about 26.5 meters, and the next point by floor, you will see later that they're going to have to get more information once we go back here, because we haven't introduced any stairs right now, so it's empty. But at the category is going to be 2, and the velocity of the wind could be something anywhere here. Well, this building has to be located in this area, which is Bogota. Bogota is the capital of Colombia, so it's going to have, let me check, Bogota is number 2, which is 28 meters, okay? So over here, I'm gonna change it for 28. The category of terrain, I'm going to use number B. I'm going to choose that one, and it's flat. That area is flat. And for a second order defect, we are going to consider that order defect. This value goes between 1 and 2. I recommend, or we recommend, the value of 2 for concrete buildings. So accept that, right? So the following is about the seismic loading. I continue with this Colombian normative, which is here, right? I'm going to analyze the method by dynamic or modal spectral. This value, let me show you. Yeah, this value, because of the area that I already chose, this value of coefficient of dissipation, no, let me close this one, sorry, 1 second. Because I'm in Spanish and I opened the Spanish version, I'm sorry. Let me close this thing again, because I opened everything in Spanish, I'm sorry. Say, let me finish this. I'm sorry, Francisco. I'm going to open the English version. Everything is upside down today, all right? So this is the example, one of the examples that we're going to use. I'm going to keep it aside because we're going to see it later. You can click here. I'm going to open one more time the software, the same software. So let me check. One second. I'm going to put it aside. And then one more time, just to start the example. Okay. Well, it's good to know that you can open the software several times and make the best of it. So we go back, we're going to a new one. We call it 26 story building. With central core. Okay, I'm gonna copy this and put it in the back, accept it, and empty job. Good. All right. Okay. You see, now everything changed, but doesn't really matter because the example is how to introduce the structure. About the wind, we already gonna do it quickly. Colombia. In this direction is going to be 126.5 meters and 26.5 meters. The category of wind is summer true, and this value I think it was 24. And the category of land is B, and is flat land. As a secondary effect, is going to be 2 here, and accept it. Good for that. We continue with the seismic load. I'm going to set up this thing for the dynamic modal spectra, and this coefficient is going to be number 8, I think. Yep, I think it's, yeah, could be 5, yes. And it's going to be a regular structure because you see it, and then previously that is regular. It's located in Bogota, the capital, and is close to the mountains because this land used to be a lake long time ago. And the kind of land, if we go in the center of that valley, the soil is very mild software. It's not very consistent soil. It's not very straightforward. It's not consolidated soil. So if you go close to the mountains, the soil is good. So that's why I'm going to choose this part of the building. So about the estimation of foundation period for structure could be based by the code and the number of verifications or by version mode are going to consider it automatically, and we're going to admit 90% of the mass excitements. And also this building has underground structure. We are going to have 2 basements. And about the rest, I'm going to do it I'm not going to consider the vertical seismic component. The base shear condition verification based by the code. For the second order effect, we go for the P delta method. For concrete, we go as well by 2, number 2. The spectrum, design spectrum is like this because all the setup that already had and accept that, right? So this is it. There is something else that I can show you. Could be the additional load cases. For this normative, we have 3 categories here: the general, the garage, and roof. I remind you that later on I can come back here and do an extra and use an extra category. But for now, I'm going to keep it with simple, like a general one. So we have for wind 8 conditions, for earthquake 2, and the other ones goes by default. I'm sorry. I'm not going to touch anything else. Okay, the only things that you might be sure is that when you use the seismic load horizontal force, that let me check. Yeah, over here you must look for this information. Let me check. Maybe the last one. Yeah, no, that's okay. Everything is okay by default. Once it's done, just close here and accept it. And now we are inside the building. We can start introducing the floors. We're going to do new ones, a single one, and There are several ways to introduce the entire structure, but at the normal height are going to be 2.8 meters, and the light load and the load for now, just for now, I'm going to keep it 0 and 0. Later, we're going to fill it up the information. After that, I can change the number of floor by 26 because they're supposed to be like this. By default, you get this information. The only modification that I'm going to do it is the height is to 50. Yeah, 250 is going to be the top. These two floors are going to have this altitude, this height, and accept, right? So we go back now for the edit group. An edit group, as you see, the category is used, we are using number 1, which means the general condition. So the last 2 floors, they are the only ones who I changed the height. Okay, and also when you edit the floor, you can edit the floor. You see that the total height are going to be 7220 meters of elevation. But at, I'm going to consider 5 point minus 5.6, sorry, 5.6 meter underground, because this is the ground level. This is the ground level, and floor 1 are going to be the yeah, could be the basement, and the foundation, it goes by default, right? So this T2, the foundation is by default, basement we admit it, and the ground floor. From now on, we have automatical description about the floors. You can also change this if you don't like floor. You can make it a study building or whatever. So the total height are going to be 66.6. When I set up the seismic conditions, I already told the program that I'm going to consider underground structure. So once they are going to do the analysis, the seismic analysis, they are going to take into consideration that part. Okay, accept that. Now we start joins the groups. That's the best way to going faster. And if you click here, and you will see in the bottom that you're choosing floor number 3 and floor number 4. If you click here and say OK, that means that this floor are going to exchange information. If I modify one of them, affect the other one. So I'm going to take as a reference the floor number 3, and we go back here for the same thing. And if we try to put the cursor on the right side in the right place, you see on the bottom that now we're choosing for floor 3 up to floor number 5. So you click there and accept it from the bottom. We go back to the join group. We go like this. Now we are choosing number 3 up to 6. Okay, from the bottom. One more time, and now you are choosing from number 3 up to number 7. Okay, this is it. I'm doing this because that part of the building, we are going to use it as an office. So the following steps, the following stories, which is the number 8 and number 9, I'm going to use it for just a very specific office. Not not so many people working in that area. It's going to be private, and these are the conditions, the original conditions, or the initial conditions of this exercise. So I'm going to keep it like this. So now we go back to the floor 10 and 11. Accept that from the floor, from the ground. We go back again for the same thing. Now I'm choosing 10 and up to 12 from the ground. Same thing. So I'm going to choose 10 to 13, and we go back. We go for the 14, and this is another group. Okay, this group could be a residential area, could be something else. And now we go for the next group, which is the 15 and 16. We continue move forward on top from 17, and we go to 19, up to 19. Okay, and let's check up to here. That another group. This part of the building, we are going to use it as a residential area. Could be homes or whatever. So we continue with the 20-story building. Here, 20 and 21, they are working together. One more time. 20 up to 23 is going to be the maximum. Yeah, up to here, okay. The remaining floor, maybe they are going to use it as a cafeteria or something like that. So the exercise like this, then this area are going to use it for offices. The second and third one and fourth one are going to be residential. And these two floor, 8 and 9 floor, are going to use it as a private offices. And on top could be located for a different purpose. So because of that specifications, we need to choose what kind of group we kind of now we have a resume here. I'm going to display this a little bit. Okay, we can see that we have a resume now about our choices, and now we have to modify the load. Okay, so that load, for example, if we do this up to the ground, I can change the live load by, for example, 0.41 and the other one 0.40, right? And you see that they copy the same value everywhere, from the bottom to the top. But for dead load, talking about the foundations, I'm going to keep it 0, okay? For the next section, which is going to be from roof 3, 7 up to 9th, this section up to 9th floor, the value are going to be 0.31, 0.20, right? The other ones, the remaining ones, up to yeah, from the 10 up to yes, up to, yeah, could be up to the end. I'm gonna keep it here, values about 0.20 and 0.20. All right, because different values. Remember, depending on the category, you check the code. These values are already you already know by code what is going to be the load here. All right, finished with this. This is an information regarding to the load. And now, from now on, we can start working with the columns. So I have to click here. We go for columns. And as you see, the only option that we have is the new column, the new chart walls, and new star. But I prefer, to use DXWG files because it's more interesting to to get to know how to introduce these files. you must click here in the edit template. Let's check. I already have 1 second. You have to introduce the new template or new profile. Click here in this class, and the software by default are going to look for places that you are working with previously, and also the people who knows better the software, or they get to know the programs, knows that once you are working with this, the software keep information on the track. So if you start a new job, by default, they try to get part of the information inside. So I was using this previously to in order to know the program, not to show you the seminar. So he keep this information, so he knows that I'm looking for these files. So I chose all of them. So now they are loading the information here. It's already here. Accept that. Now we have an extra job to do it, because the software doesn't know which template, which place are going to use the template. So I must get it done. So this is an extra information. For the column foundation, I'm going to choose this profile. For foundations and basements and ground, I'm gonna keep it like that. For the roof, number 3 up to 10, up to 7, I'm going to use this template. For number 8, I'm going to use this template, and number 9, that one. For now on, I'm gonna change to this template from 10, this template, 20 to 30, this template. The other ones could be anything, right? But this is the way to do it. Once I close here, I can start working using the template. But at the same time, to the right side over here on top, you will display the view selections that you want to work. Perhaps right now we are in introduction or definition, in column definition, but later when we move on to bin definitions, we can start going up and down, and you can choose if you make a mistake here, don't worry, you have to open here and try to display the profiles anywhere, depending on your location. So now, if we go back to the column and chairs, I have to do a new column. As you see, by default, the program give you the minimum width and in X and white, but it's going by 30 by 30. So normative, I start with 25, but in this case, the Colombian normative, the minimum size is 30 by 30. But even so, you can modify this value. I'm going to choose it. I'm going to do it. I'm going to keep it 60 by 60. But you have to know that when you do this, initially these values are just as a reference, because later when you do the analysis, the software will adjust according to the effort and stress and the kind of information inside the software. You have to work a lot in order to get the best solution. So I'm going to keep it 60, but the columns that are going to introduce are around the perimeter of the building. And also, I'm going to change the reference by P, because I like the pillar instead of going by column, and with external electricity. So we accept that. So I'm going to start with number 1. So we have an extra feature here. I better to choose this, clear all, and select just one. Sometimes this is the best way to do it, because when you are using templates. The templates became, too much information inside, and perhaps you get a mix up and choose different options, especially when you are using grid or whatever. So I'm going to finish. Let me check. All right. It's very simple. I'm going to do the external walls. So I'm going to keep it like that. I'm going to skip that part because I'm just doing it the external ones. So this is a little entertaining, no? It's not so difficult to finish it. Just make sure that you are clicking in the right place. Don't rush. You better go easy by truly. We almost done. Oh, sorry, aquí I have something wrong. Okay, when you click in the right place, the program knows exactly that's it, the position. So they go straight, and you can introduce the column without any problems. But when you click in the wrong place, they ask you for coordinates in X and Y. 1 second. Okay, so I finished the one around. Now I have to do the one inside because this is the central core. For the central core, I'm going to click because I'm going to change not up to 24. Sorry. There is something wrong. Something. Okay, so we continue. So the new column, I'm going to displace this column over here. Over here. That one over here. I have to go back here because this is not the right place. Let me check. Yeah, they are going the line. New column. Let me check. Let me check. I'm going to verify something. Yes. Okay. Uh-huh. No, 1 sec. There is something wrong here, which is this. Okay. No, no one. Okay. So we move on to the columns. Give me 1 second. So we move. We continue with the columns. I don't know what is going on. Okay. So accept that. So I'm going to continue here to click here. I'm going to continue here. One over here. Okay, so I can change a little bit this one, but I can use the move command. Do it like this and click here. Okay, so this is it. I can now finish here, and we go for the bin definitions. About the bin definition, right now I am in. Let me display this better. Oh, this missing one column over here in the corner. So floors, I'm sorry, columns, a new one, and the same thing. It's gonna be here. I missed that. Okay, so we go for bin definition. Now I'm gonna start using the basements. So from the first floor, I'm going to use the wall definitions. I'm gonna keep it 30 centimeters width. I think for this exercise, I can do the foundation fixity, accept that, and we go straight from one place to another. That's the around, choose around. And also I can start a new wall. Well, I can edit the wall, edit that wall, and choose the pressure diagram. You have to click and adjust a new one. So the situations in the load case scenario is self-weight. The up to elevations are going to be 0 because that's the case. This is the ground. And for the loads of field, I'm going to add 1, could be a uniform load, and I can keep it 1 ton by square meter. Accept that. Now I have to choose the location. Location could be right or left or right. I can try right, for example, maybe left, but don't worry if we don't make it, you can come back here and do it again. Accept that. If it's low, look, if it's okay in the center, you will see the right location. On the opposite side, we go for the pressure diagram. I click here, and now we keep the same information. I'm going in the right direction. Okay, I make it right. For this side, we go back to the diagram, click another one, and perhaps it's left or right. I don't know. I'm not sure. I'm gonna keep it right, but depend on the way you introduce the. This is not the right location, so we go back here, and now it's left. And from the one at the bottom, this is more simple. It's right. Okay. So I almost finished this part. It's missing one column. Remember? Well, it's just to show you how to introduce it. So for the next step, we go for the wall definition again. Now, these core are going to be from the ground up to top. Okay, so I can increase this value of the right and right, but I want you to know that on the starting from the ground, this width are going to be higher in the beginning, but as soon as we are getting up, these values are going to modify for sure. So I prefer to change these values here, for example, by 20 and here by 40. Because depend on the way we introduce the wall, are going to be 60 width centimeters, but later maybe in somewhere are going to reduce this width, and so on and so on. Perhaps maybe in about 7 floors up, I will get 20 by 35, and later on top, I will change it 20 by 30, and see until and so on, so on, so on, until I get the top. For sure, that's the best way to make sure that that we're going to in a different geometry as soon as we are getting higher. Okay, so when is this? I can go and choose the last ground. Okay, the top of the building, and we continue with the fixity. Accept that, and now I can go like this. I can go like that. I can go like this, and like that. Okay, so one thing that has to be sure, you must be sure that oh well, we are in the basement, so I'm supposed to be in the ground. Okay, so I can make it straight if I want to, using the command move or adjust or move. When I use move, the program, as you can see, they take the entire world and move it in the way that I click in that direction. But with the right click in your mouse, you can set up that increment, that displacement. Now is 0.09, and but you can change that as well. Look at like that. The software try to do the best, to do it. You must click in just one side. You don't have to click in both sides, one on top. When it's done, we can continue on the next floor. In this floor, for sure, the quotation mark that you are seeing in yellow color means that we must choose the slab. About the slab, I'm going to make it simple. I'm going to continue with the fly slab deep 15. Click one times in the center and went to the one of the lateral ones. Beside that, I can go back here, make it, I'm going to choose this plane. So the basements, they have, I know for sure that the lift area are going to be over here. We have 2 lifts in the right side and the left side, and wing for cargo. This is for heavy duty stuff. And from the one on the bottom, they have 3 lifts over here, and on the back on the side we have another hole, which is the stairs location. One thing that I want to make sure is that we need some reinforcements in this area. So I'm going to introduce a new defined beam, which is going to be 40 by 80. In this case, it's going to be very reinforced one. If I'm getting problem with this selection, remember this part, I'm going to keep it like that, And now I can go a little bit, I can make it straight using the orthogonal command, and one over here. Okay, so I'm going to make support around this, and also, well, yeah, that's okay. And now I can use another the beam definition, which are going to be these ones, just to close this area. Okay, here, over here, right? In this place, well, it's going to be from here up to here, right? I'm going to connect that point with this point, right? From the wall, I'm sorry, from the stairs, I'm gonna make a little. You cannot, yeah, you don't have to be precise, because okay, good. And then there we have an options about the slabs. When you display the panel definition, you can introduce an opening, which is this is an opening, this is an opening as well, this is an opening. Okay. Okay. One extra feature, I'm going to get rid of this DXWG file. And the next step is to make sure that we have to add any extra load. Okay, about the extra load, I'm gonna introduce, for example, just for for fun, could be 3.86 tons by day load. That could be day load in as a new one in this area over here, because these are going to be the stairs in these two parts. I'm going to change it for about 0.46, for example. Point is too much. 0.36, 0.36. Also the load, a new one, and could be from here up to here, from here up to here, and like this. Okay, same thing from this side. Okay, good. So and then there are some kind of dead load, extra load that you might take in consideration once you are going up, but it's up to you. My exercise here, my intention in this exercise is to show you how to use the software, how to get just to know how to do a high building and skywrap building and taller, the features that we have in the column definitions to get just to know the commands, normally the commands. Well, okay, I want to show you a little bit what we are doing. Okay, something like this. So on the bottom, we must introduce also in these dark colors, we don't have any foundation slab definition. So make sure where we are over here, you can displace the entire structure. We go back here, the ground is okay. We move on top. On top, we have the foundation, the slab in the area, and also the holes. We can start also introducing holes in the structure, but not for now. The thickness of this slab is when I chose already 25, and on top of these walls you will see a beam with the same thickness. So if I want to copy this information on top, I must go on top, because right now we are here, okay, in the green color. So I'm going to copy this on top, the one on top. So the best way to copy on top is to go up a little bit, and then in browns, copy from another group. So I'm going to copy from, I am on top, which is ground number 2, and now I'm going to copy from the basement. When I choose that, okay, now we have it. I'm gonna show you what we did in 3D, just from the ground to, sorry, from the foundation to the ground. Accept that. That's what I did. This is the flat that I'm telling you. It's very slim flat, a beam, I'm sorry, and the holes, and that's what we are. Okay, continue. Then I'm going to move forward. I'm going to copy this information on top, which is going to be here. So in order to copy, I can move on top. Now we are on top, and then I can go back to the ground and say copy from the another group, which is the one on the bottom, and it's done. I'm gonna show you, for sure, we have some things that we have to change it, but like that, we are going up. But I forgot, to do to connect in the ground, the build the beams. So I go back here. So I'm gonna do the walls, the beams definitions. This beam definitions, I'm gonna keep it 35, for example, 35 by 50, by 35 or by 40, now 50. So I need to do this. Well, no, it's missing this. It's missing the point here, but I'm gonna make it anyhow. We can go back and introduce that missing missing column. Okay, so go on top, move on top. I can introduce or I can copy from the ground, whatever you mean, whatever you want. Same thing, same beam. We're almost done. Don't worry. Don't be patient. Good. Then we go on top, but you see the beams are not in here. So I can go back, to the group and say the same thing, to copy from the ground. Now you get it. So we go back. So now we're getting better. I need to change now the perimeter wall beam, which is very slim. I need to go back. Any modification that I'm going to do in one of the floors, for sure, are going to affect the other one. So for this, I have to assign the beam. I'm going to select that one because I know that's the good one. And then I can do like this. I can do like this. If I make a zoom in, zoom out, I will see which one is missing. So like that. Okay, good. So it's okay. When it's finished, right click, finish it. We must verify that our job is well done. Good. So we did it okay. You see, we are fine. And then I can show you another things. I can make a holes. I can make the holes. So we go back, for example, to this floor, and I can ask the software. As you can see, we have a door over here. It's written. You can read it, but the software has in walls openings. I'm going to do the door foundation, the introductions. I'm going to increase it by 1.5 just to make sure that it's going to be okay. So when I want to do it up to here, something like that. Okay, like that, and the other side, and the opposite side, the same thing. So I finish, cancel, and we go back again to the 3D view. Okay, so You see, you can introduce any opening. Okay, from now on, it's just to copy, it's just to copy from that. Now we have groups, so we are going faster. I'm not going to continue doing it because it's a very repetitive process. But that's the way to introduce the entire building. It's so easy with the software. And beside that, remember that we need to use different aspects of the software. And for example, I'm going to show you the 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 job already done. Which is the let's see if it's this one. No, this is a new one. 1 second. Okay, good. So finally, the assignments, when you did it okay, has to be something like this, right? The ground, the bottom, this is the ground. You have the openings, you have the load conditions. You can all these things you can introduce it in one the floor, and as a group they're going to copy on the other ones. I know the results change a lot. So if I go back to the column definition, if just to make sure that I'm going to use the edit command, and the edit command about, for example, one of the external columns. Remember that we start with 60 by 60, but 60 by 60 will be okay up to floor number 10. The result of this structure is already done it. So from that size on top, the geometry is changed a little bit. Then on floor 16, from floor 17 up to the floor 19, 18, 17 and 18 is 40 by 40. And then we go from the 19 up to the 20, 35 by 35. And that from the 20 to the top is 30 by 30, right? So as you see, these geometry change accordingly to the effort, and also changed by the walls. If I go back, for the wall definitions, the final results about the walls are going to be something like this. I'm going to edit, for example, this one, and from the bottom, I got 20 by 24, 20 by 40, and up to floor 6. From floor 6, I change the geometry change by 20 by 35, and we go forward, and the last 20 by 20. Okay, so over here in the top left corner, in the chairs walls, if I choose the chairs walls, I can calculate this, the analysis. With this analysis, I can introduce to the bin environment platform. I can introduce the same structure, and I can synchronize this structure with the one already created in Bin Center. And over there, I can continue using the software TH Vault. And with that software, it's possible to be sure that in these segments of vault, the software are going to analyze if it's possible to introduce an extra reinforcement. right now we are using columns, but with using the shears wall designs, the edges elements are going to be there because the software already introduced the effort coming from CYPECAD and you use it in the software. So you will be able to find this information right there, and you can also get plans and drawings and extra extra and documentations supporting your calculations. So let me close here. And what I'm trying to tell you is that over here, in previous seminars, I showed this exercise where you can define the connections between walls with another column, another beam. That beam is called a Doppler mean. That Doppler mean also is calculated with the software shears wall design, and give you the reinforcements. They give you the requirements to fulfill the code that we are using. Right now, we can use the AC code and also Euro codes and the Mexican code as well. And we are going forward. I think this is it. But it's the same scenario. The building that I already showed you could be possible to do it in different way. Which one is better? But I recommend you the latest version, which is the shears wall design, which is the best solution because it gives you more information regarding to the accurate about the calculations, and also that you will take advantage about the just to make sure that what you are doing is okay. This software shares well design is one of the kind. It's a lot of calculation going on inside the software because they use a lot of routines, and that save you time, and time is represents money as well. Okay, I think this is the end of the conference. I hope you like it. Thanks so much for being here. I'm sorry to keep you waiting. We have sometimes problems on the net. This is one of the problems that we have in the morning. I hope you like it, Francisco. If you have any questions, just let me know. I open the mic for you. If you have any question, please let me know.